Elon Musk and NASA have unveiled a light-speed engine that is faster than anything previously seen in the aerospace industry after years of testing. With the same goal of exploring the farthest reaches of space, NASA and Musk have been working together for some time. The successful testing of this new engine represents a step closer to their goal. But what sets this engine apart from others? Can it safely arrive after surviving the meteorite adventure? Here are a few explanations for why diverse scientists' opinions on the possibilities of the new light-speed engine differ. Welcome back to another exciting video from Informative Scoop. Today's video is about Elon Musk and NASA finally reveals new light-speed engine that defies physics. Before we start the video, please like, subscribe, and press the bell icon. The problem with space travel. By the year 2050, Elon Musk hopes to enable successful human travel to Mars. Elon has a reputation for producing results, so NASA is collaborating with him to make that happen. However, the idea of space travel has been fraught with difficulties, particularly a trip to Mars, the fourth planet in our solar system, is 140 million miles from Earth on average. Therefore, it would take a rocket traveling at 15,000 miles per hour for at least 7 months to reach Mars. Methane, as opposed to kerosene, is the main fuel utilized by modern rockets. Furthermore, for a successful flight, this fuel must be prepared in advance and put into the rocket before liftoff. However, a rocket that uses 11,000 pounds of fuel every second day would need how much fuel, space, and fuel? The reply is a big one. This is taken into consideration while building a rocket to undertake such a hazardous voyage, as designing spacecraft necessitates striking a balance between the weight of the vessel and using fuel as sparingly as feasible. Take a peek at the Starship that is now on a unique mission to Mars. In that situation, only a small piece is set aside for them, and the majority of the compartments that contribute to the craft's weight are used to contain fuel and supplies. The spaceship is 120 meters above the ground and has 33 Raptor engines, which can produce a thrust of 500,000 pounds. It will also be challenging to have enough fuel for a trip to and from Mars, although the engine is built to be fuel efficient. This explains why robotic missions using smaller rockets have been the only successful Mars missions so far. If they were to use aerobraking to safely insert the rocket into Mars orbit, that would require additional fuel added to an already hefty vehicle, as there was no need for astronauts' extra fuel or supplies needed for the entire mission. Even a space enthusiast like Elon Musk is aware that the path ahead will be difficult. As he indicated, such a journey will be hazardous, uncomfortable, challenging, and demanding, but worth it. The potential of the new engine. The third rule of motion, which states that the action and reaction forces are equal in magnitude and opposing in direction, is typically the foundation for chemical rockets. In Falcon, this hypothesis is realized. A fuel like methane is mixed with oxygen in a combustion form for the Space Shuttle and the current Starship, both of which use thrusters to produce thrust. This light-speed engine seeks to accomplish something different from the usual practice of accelerating liftoff by channeling hot exhaust gases, steam, and water through a nozzle. Describe the rules that have been established. It won't require a propellant to move. Space relativity states that objects gain mass as they get closer to traveling at the speed of light. The engine works by enclosing ions in a loop, accelerating them to modest speeds, and altering their velocities just enough to modify the mass of the ions. To produce what is required, the engine will cycle the ions back and forth in one direction. The engine will resemble a stretched out thread and will take on a helical structure. The only moving components will be the ions restrained inside electric and magnetic fields. The electromagnetic drive, a contentious propulsion technology, is what this light-speed engine plans to employ to generate thrust without a propellant. According to David Goodwin, any rocket can travel faster and farther into space than with any other propulsion system if the vibration from electromagnetic waves or ions can be focused in one direction. It might develop a propulsion system that is efficient enough to reach speeds of less than 1% of the speed. Subscribe to our channel if you like this one and want to see more. However, the concept of producing propulsion without any fuel is not new. Goodwin oversaw a NASA breakthrough propulsion physics project in 1990 intending to create a propellant-free propulsion system. In reality, Roger Shur created the first instrument demonstrating the concept of a reactionless drive in 2001. Why are scientists opposed to the new light-speed engine if it has such great promise and can help humanity realize its aim of exploring the upper heavens? The setbacks of the engine. Scientists from the US, the UK, and China have shown how electromagnetic propulsion works since the initial demonstration in 2001. However, some argue that now is not the time to celebrate because no one is certain how the propulsion will be used as the prior experiments were not conducted in a vacuum, leaving any certainty on its actual practical use. According to some, producing energy in a quantum vacuum is impossible since you cannot ionize particles there. Before the project ever gets off the ground, measurement errors and ambiguity might result if these studies, assessing a modest effect of the guidance, were to be deemed significant. We must think about how much it will cost to operate. It would be very expensive and time-consuming to use an M drive. It has already received $5 million from NASA, and it is unclear how much more will be required to improve it. Moreover, developing momentum in rocketry without a similar trigger. Ancient attempts to do so not only defy Newton's third law of motion, but also the law of momentum conversion, which stipulates that an object's momentum stays constant in the absence of an external force. It doesn't seem conceivable that this new engine will surpass the limits of recognized physics that apply to all known forms of motion, because the idea of momentum conversion is well established in physics. Would the rocket be able to withstand media coverage? 2. Correct ordeal: a meteorite travels at 120,000 miles per second as it approaches the Earth's atmosphere. It burns ferociously as it travels through the atmosphere of the Earth before settling into the Earth. We now understand that a meteorite is a piece of cosmic rock strong enough to survive impact with Earth. Can a rocket powered by an M-drive withstand the same impact? Though, it might burn upon return if it moves at the speed of light, which is a bad outcome. Also, rockets had to be fired at the ground during earlier Mars landings to halt the descent. How will the new rocket make a successful landing if it doesn't intend to use thrusters? The spaceship needs to have the right propulsion system, since the atmosphere on Mars is dense enough to burn the rocket upon entry. A team from Dresden University led by Martin Tammer finds a weakness in the new light-speed engine, much to the delight of naysayers. The test revealed that another electromagnetic interaction, rather than the M-drive, may be the source of the push. The study claimed to have found significant gaps in earlier research that suggested it could be hard to build a functional light-speed engine. Nonetheless, NASA has succeeded to disprove other researchers' skepticism. An M-drive was put through some tests at EagleWorks Laboratory by a team of researchers working on a NASA-funded study to see how it might perform in deep space. Through these tests, it was demonstrated that a thrust-to-power ratio of 1:4, which was higher than any estimated prediction for the drive, was feasible and opened up new opportunities for discussion of outer space. Additionally, Roger Sher defended the M-drive by claiming that the well-praised negative tests were based on an inadequate design and should not be taken seriously. It is impossible to entirely discount the drive as a possibility for space travel given the conflicting views and results of the tests conducted on it. From all of this, it is obvious that Elon Musk and NASA will need to use all of their imagination and experimentation to develop the engine. Still, when it is finished, it will be among the most crucial steps taken by humans to become a multi-planetary species. Do you think research should be done on the next light-speed engine? That's all for today. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.